Literal equations are that's some fancy math language for what we're going to be doing here is taking an equation and solving it for a variable. We're not actually going to solve the equation. What we're really doing is moving terms around within the equation. There are two tricks to solving literal equations. One of them is to clear out the fractions. If the equation that you're working with has a fraction in it, use the tricks that you've learned to get rid of the fractions within the equation. If you remember, we do that by multiplying by a common denominator, and we have to multiply every term by that common denominator to get rid of the fractions in the equation. The second trick that's sometimes used is factoring. And the trick is noticing when you need to factor. And that's almost always done if the variable that you're trying to solve for appears in the problem twice. If you're told to solve the equation for y, and you see more than one y in the problem, then most of the time you'll need to factor in order to get the y to appear in the problem just once. Now those are two tricks that you're sometimes going to use to solve literal equations. Now the two tricks will not always be used, but they're important to keep in mind when you're solving literal equations. Let's take this example. Here's an equation, 1 over x, excuse me, this was supposed to be a plus sign, 1 over x equals 1 over y plus 1 over z. Now we have three different variables in the problem, so there's really no way to solve this equation. But the directions are going to say to solve for x. They're going to pick one of the variables and ask you to get that variable on one side of the equal sign by itself. So let's see if we can do this problem. We're going to use the first trick I was just talking about in order to clear out the fractions. I need to identify what my common denominator would be between an x, a y, and a z. Well, that common denominator is going to be x, y, z. And I'm going to multiply every term of my equation by that common denominator. When I multiply x, y, z times 1 over x, notice the x's cancel. And I'm left with y, z. When I multiply the x, y, z times the 1 over y, the y's cancel. And I'm left with x, z. When I multiply x, y, z times 1 over z, that time my z's cancel and I'm left with x, y. Now I'm trying to solve this equation for x. I want just one x on one side of the equation by itself. Well, this isn't a good example of when I would be able to factor. Do you see that I have two terms, and both of the terms have an x in common? So on the right side of my equation, what I can do is factor out the x so that the z plus y are left. I've not done anything to the left side of my equation, so the yz is going to stay over there. Now how can I get the x to be on the right side by itself? How is the x connected to this quantity in parentheses? X is being multiplied by the parentheses. So what I can do is divide both sides of my equation by z plus y. So take yz and divide it by z plus y. That messy value is my solution. I have solved my equation for x. I was able to get x on one side of the equation completely by itself and everything else on the other side of the equation. So in that example, I used both of the tricks that I referred to. I cleared out fractions and I factored. Let's look at another example of a literal equation. This time I'm going to have variables that look like this: y minus y with a little 1 on the end of it, equal to m, and then in parentheses x minus x1. Now this is an actual math formula that you'll deal with when we do graphing. The little y1 and the little x1 are different than the y and the x. In fact, they could have used an entirely different letter to represent those values, but instead they chose to mark it with a little 1. All you have to do is realize that that y1 cannot be combined in any way with that y. Recognize that these are two very different variables, even though the letters look the same. The x and the x1 are also the same way. They're not ever going to be able to be combined because they're different variables. So again, my directions are going to say, solve for x. I want the x to be on one side of the equation completely by itself. I'm not looking for the x1, I'm just looking for this x right here to be by itself. What I need to do first in this equation has nothing to do with the left side. What I need to do is multiply out these values on the right side, which means I'm going to have to use the distributive property, because I want to be able to get this x by itself, but right now it's being subtracted and multiplied. So let's go ahead and do the multiplication to get mx minus mx1. Now I'm shooting to get this letter right here by itself. So let's take this minus mx1, and let's take that entire term and add it to both sides so that it cancels from the right. So if I add mx1 to both sides, I'm going to add it over here as well. On the right side, I will just have the m and the x. The left side then is going to be y minus y1 plus mx1. Looks very messy, but there's nothing that I can do to combine that because there's no like terms. Now what can I do? That m is being multiplied by the x that I'm trying to get by itself. Since they're being multiplied, I'm going to divide by m. So I'll take the y minus y1 plus mx1 and divide all of those terms by m. Well, y over m, there's no way to simplify that. Minus y1 over m, there's no way to simplify that. Plus the m in the mx1 over m, the m's are going to cancel, so I'll have the x1 there with no fraction equal to x. So this finally has the x by itself on one side of the equation, so that I've solved the entire equation for x.